Today we're going to talk about writing expression for perimeter of area if we are given a variable or an expression with a variable instead of just the dimension of the sides. So first thing we want to note is we want to write the expression for the perimeter area, and then we want to simplify if necessary by combining like terms. So we are going to write our own expression for all of these. So first things we need to remember is for perimeter, that is going to be the sum of all the sides. So just the outside of the shape. And just a reminder that regular polygons have sides that are all equal. So they're all equal in length. So if it says a regular pentagon like example 1, that means all of the sides of this pentagon are going to be the same as the given x. So here in a pentagon we have 5 equal sides. So we have 1, 2, 3, 4, 5. And if they're all the same, that means they're all going to be x. So the way I would write that, I would do x plus x plus x plus x plus x. So I'm just writing an x for each of the sides. Now we can combine like terms. We have 1, 2, 3, 4, 5. So our simplified expression would just simply be 5x. Looking at example number 2, we have a square. So that says x plus 4, and again with this square, we know squares have all equal sides. So this right here, all the highlighted is the perimeter, and we know that each of those highlighted areas right there are going to be x plus 4. So then I would write x plus 4, x plus 4, x plus 4, x plus 4. I'm just going to go ahead and rewrite it so all the x's are up front together and all the 4's at the end. So I should have a total of 4 x's and then 4 4's being added. So when we combine those like terms, I would have 4 x's plus 16. And again, all we did was write the expression x plus 4 4 times and then combined our like terms. Now let's go ahead and look at examples 3 and 4. So here, this is not a regular triangle. So this marking right here on each of the sides, this is an isosceles triangle. It says 2x and 2x on both sides. And that little marking means that both are the same length. So I have 2x plus 2x plus just x. So let's go ahead and write that out. 2x plus 2x plus x. So we're going to combine our like terms. We have 2 plus 2 is 4 plus 1x is going to be 5x. Now looking at example 4, we have a rectangle here. So just to note that this x minus 4, we know the properties of a rectangle. The top and the bottom are both going to be x minus 4, and then this side 2x, and the right side are also going to be 2x. So just a visual there so you guys can see that the yellows are both x minus 4 and both of the blues are 2x. So then here when we write this out, we're going to write 2x plus 2x and then x minus 4 written twice. Remember, we're adding in between each of those expressions. So you have 2x plus 2x, so for the blues, and then x minus 4 plus another x minus 4. So when we combine our like terms, we have 2, 4. Remember, each x by itself means we can say that that's 1x, so that's 2, 4, 5, 6. So we have 6x, and then combining the negative 4 with the negative 4 there. So we are going to get 6x minus 8. Now let's go ahead and look for area. And just a reminder about area. Okay, to find the area of a rectangle's length times width, and with the square the same thing. The only thing is we know that square, all the lengths and widths are the same. So let's go ahead and look at the first example. So we have that one of the dimensions is x plus 5, and then we have the second dimension is 12. So what we need to do is do 12 times x plus 5. Let's be careful on how we write it. So that would be 12 times the quantity x plus 5, keeping that expression in parentheses so that way we know to distribute. So we're going to do 12x plus 12 times 5. So we're going to apply the distributive property here so that way we can make sure that we're doing it correctly. So 12 times x and 12 times 5. So when I multiply 12 times x, I simply get 12x, and then we do plus the product of 12 times 5. So our final simplified expression would be 12x plus 60. So let's go ahead and look at example 6. So this time we have 9 times 3x plus 2. Remember to keep that expression of either the length or the width inside parentheses if it's more than one term. Okay? That way we know that we're multiplying it. So we're going to do 9 times, and inside parentheses 3x plus 2. So again, we want to use a distributive property, so we're going to do 9 times 3x and 9 times 2. So when we do that, we get 9 times 3x and then plus 9 times 2. So 9 times 3x would be 27x, and then 9 times 2 would be positive 18. And then we have our simplified expression. So let's go ahead and look at the next two examples. Knowing that this is a square, I know, because they told us it's a square, okay, that if the length is y, the width is also y. So y times y. And a better way to write that would just simply be y squared. So example 8, we have another square, and we have 2x. That means if the length is 2x, the width is also 2x. So we're going to do 2x times 2x. Now we would multiply our 2 times 2, our coefficients, and then our variables x times x. So using our properties of exponents, this turns into 4x squared. Okay? So simply all we did on this side was just to write the expressions of either the area or the perimeter of each of these figures based on what they asked us to do. Now if we go ahead and turn our paper to the back side, we are going to use algebra to find the missing side. So what we're going to do is actually set these expressions that we solved earlier and set it equal to whether it's the perimeter or the area. So the steps we want to follow is we want to write an expression, okay? And then we're going to take that expression and make it equal to the given information. So we're going to end up making an equation this time, not just an expression. Remember, an equation has an equal sign. And then we're going to solve for the variable using our steps that we know to solve equations. So for example 9, we say we have a regular pentagon. Again, this pentagon with 5 sides, and because it's a regular pentagon, that means all the sides are going to also be x. And it's telling us that the perimeter is going to be equal to 22.5 inches. So that means if I add up all the sides of this pentagon, it should equal 22.5. So the first step here is I'm going to go ahead and do x plus x plus x plus x plus x is equal to 22.5. So I have 5 x's that we're adding. We're going to combine our like terms to get 5x is equal to 22.5. Now we have a one-step equation. We want to divide both 5x and 22.5 by that coefficient of 5 to get 1x. And so our answer when we divide 22.5 divided by 5 would be 4.5 inches. So another way we can check is we can plug in that 4.5 in for x and then add 4.5 5 times or multiply it by 5 to check to make sure that we get 22.5 inches. Alright, example 10. We have a square and the perimeter of the square is 56 centimeters. So that means I added all 4 sides, and all 4 sides are the expression x minus 2. So that means I'm going to be adding x minus 2 4 times. So what I did is just a little different approach. If I know I have 4 of those, I can multiply it by 4. So again, what I can do is use a distributive property to do 4 times x and then 4 times negative 2. Okay, we could have also set it up in just an x minus 2 plus x minus 2 plus x minus 2 plus x minus 2, so writing it 4 times. We'd still get the same answer, just showing you a different approach. So when we multiply each term by 4, we get 4x minus 8 is equal to 56. Now solving our two-step equation here, we want to do the inverse operation of subtracting 8. So we're going to add 8 to both sides to get 64. So now we have 4x is equal to 64. We want to get the x isolated, so we are going to divide both 4x and 64 by 4 to get 16 centimeters. And again, you can plug in that 16 in for x, solve it, and then find the perimeter of each of the sides. Okay, and getting the answer 56 to make sure we did it correctly. So now let's look at the next two examples here. Now, the next two are not regular polygons. These are just shapes, and then we know the information needed. So here we have 2x, 2x, and x. So that means I have 2x plus x, so that should give us there that expression, and set that equal to 72.5 feet. Combining our like terms of 2x plus 1x, that would be 5x. Set that equal to 72.5. Now again, we want to divide both sides by 5 to get an answer of 14.5 feet. So looking at number 12, we have a rectangle. We have 4 and 2x plus 1. So just a reminder, going over this, we have 2x plus 1, 2x plus 1 also on the bottom, so opposite sides are congruent, and then 4, and then also the right side would also be 4. So when we write that out, I went ahead and just did 4 plus 4 is 8, and then 2x plus 2x would be 4x, and then 1 plus another 1 here would be 2. So now we can combine our like terms. Combining 2 and 8, we get 10. So now we have 4x plus 10 is equal to that 100 centimeters that was given to us. Now we want to solve this two-step equation. We want to subtract 10 from both sides. So we get 4x is equal to 90. Now we want to divide both sides by 4. So we get x is equal to 22.5 centimeters. Now those were all 4 examples for perimeter. So setting up our expression and setting it equal to the perimeter. Now let's go ahead and do that for area. So here they tell us what the area of each of the rectangles or squares may be. So now we have to come up with our expression first, and remembering that it's going to be length times width. So here I have 9 times 3x plus 2, remembering to keep that 3x plus 2 in parentheses, and set that equal to the given 261 millimeters squared. We are going to apply the distributive property to do 9 times 3x and 9 times 2. So we get 27x plus 18 is equal to 261. We want to get rid of our constant first, so inverse operation of adding 18 would be to subtract 18 from both sides to get 27x is equal to 243. And on our last step, to get x isolated, we want to divide both sides by 27 to get an answer of 9 millimeters. And remember to be careful, r here would just be 9. Okay, that's what's missing. Now, 14, we have an area of 36 inches squared. Here, we have a length of 4x and a width of x. So we're going to multiply those together, 4x times x, and set that equal to 36 inches squared. Now, x times x will turn into 4x squared. Okay, and set that equal to 36. We want to get rid of the 4 first, so we want to do the inverse operation, multiplying by dividing both sides by 4 to get x squared is equal to 9. Now we want to do the inverse operation of x squared, which would be to square root both sides. When we square root both sides, we get x is equal to 3. Now let's look at 15. So here we have a square, and the area of that square is equal to 256. So again, we know that x and also the width is also going to be x, so we get x squared is equal to 256. Inverse property of squaring would be to find the square root, and we get x is equal to 16. So one more example, we have the area of this square is equal to 100 centimeters squared. So this square is 2x by 2x. So we're going to have 2x times 2x. So 2 times 2 would give us that 4, and x times x would be x squared. Setting that equal to 100, we want to do the inverse operation of multiplying by 4 to both sides, which would be to divide both sides by 4. So when you divide both sides by 4, you get x squared is equal to 25. Again, the inverse operation of squaring x would be to square root it. And so when we square root that, we get an answer of x equal 5. Okay? Now that we've finished the notes, please go ahead and complete the practice and check your answers to the practice with the answer key.